Your garden hose loses 40% of its water before it even reaches your plants. And those expensive quick connect fittings from the hardware store are the biggest culprit. Every season, millions of gardeners throw away perfectly good hoses and buy new ones, spending anywhere from $25 to $60 when a $2 fix using bicycle inner tube and a simple clamp creates a watertight seal that lasts forever. But hardware stores will never tell you this secret because they make their real money selling you replacement hoses, fancy connectors, and repair kits that fail within months. The solution I'm about to share with you has been used by plumbers and farmers for decades, but it's been deliberately kept out of mainstream knowledge because it would destroy an entire industry built on planned obsolescence. Stay with me until the end, and you'll learn not just how to fix any hose leak permanently, but why the hardware industry has conspired to keep you buying new equipment every season. The story begins with Tom Rodriguez, a 63-year-old retired mechanic from Arizona who'd spent thousands of dollars on garden hoses over the past 20 years. Every spring, Tom would head to the local hardware store and drop $100 on new hoses, connectors, and sprinkler attachments. By the end of each summer, half his equipment would be leaking, cracked, or completely unusable. Tom thought this was just the nature of garden irrigation until he met his neighbor Jake, an 80-year-old former plumber who was still using hoses he'd bought in the 1980s. Tom's water bills were astronomical during summer months, not because he was using more water, but because most of it was leaking out before it reached his plants. He'd calculated that his brand new 50-foot hose delivered only about 60% of the water that went into it. The rest was lost through tiny leaks at connection points, hairline cracks from sun exposure, and especially those plastic quick connect fittings that every hardware store pushes as the modern solution to hose connections. The problem with these quick connect systems is simple but devastating. The rubber gaskets inside the plastic fittings dry out and shrink within a single season of use. The Arizona sun, the same sun that Tom relied on to grow his vegetables, was destroying the very equipment he needed to water them. Each connection point became a miniature water fountain, spraying precious water into the air instead of delivering it to thirsty plants. Tom tried replacing the gaskets, but the replacement parts cost almost as much as new connectors, and they failed just as quickly. Jake watched Tom struggling with his leaky hose one morning and couldn't help but laugh. "You're fighting a losing battle with that plastic junk," Jake said, walking over to examine Tom's connections. Underscore, underscore, quote underscore, one, underscore, underscore. Jake disappeared into his garage and returned with tools so simple that Tom initially thought the old man was joking. What Jake pulled out was a roll of bicycle inner tube material that had been cut into strips about 2 inches wide. Along with this, he had a handful of stainless steel hose clamps, the kind used in automotive applications. Jake explained. Jake's technique was embarrassingly simple. He cut off the failed plastic connector entirely, including about an inch of the damaged hose end. Then he slipped the hose end inside a slightly larger diameter piece of pipe or fitting, wrapped the connection point with a strip of bicycle inner tube, and secured everything with a hose clamp. The rubber from the inner tube created a perfect gasket that would flex with temperature changes and never dry out like the cheap rubber gaskets in plastic fittings. The transformation was immediate. The connection that had been spraying water like a broken fire hydrant became completely watertight. Tom tested the repair by turning the water pressure to maximum and examining the connection point with a magnifying glass. Not a single drop leaked out. The repair was so effective that it actually created a stronger connection than the original factory fitting had provided when new. But Jake's bicycle tube method was just the beginning. He had solutions for every type of hose failure that Tom had been throwing money at for years. For small punctures or holes in the hose itself, Jake used a technique that took 30 seconds and cost virtually nothing. He would take a wooden toothpick, coat it with superglue, and insert it into the hole. The toothpick would swell slightly from the moisture, creating a permanent plug that was actually stronger than the surrounding hose material. Have you ever thrown away a hose because of a small hole or leak? Drop a comment and let us know how much you've spent on replacement hoses over the years. For larger tears or splits in hose walls, Jake had an even more ingenious solution. He would cut a patch from an old bicycle inner tube, coat it with rubber cement, and wrap it around the damaged area. Then he'd secure the patch with electrical tape, wrapping it tightly in a spiral pattern. This created a flexible, waterproof repair that moved with the hose and never separated or peeled off. Tom watched in amazement as Jake repaired a 6-inch split that would have meant throwing away an otherwise perfect 50-foot hose. The most impressive demonstration came when Jake showed Tom how to join 2 shorter hoses into one long one. Instead of buying expensive coupling hardware, Jake used a short piece of PVC pipe that fit snugly inside both hose ends. He slipped each hose over opposite ends of the pipe, wrapped the connections with bicycle inner tube strips, and secured everything with hose clamps. The result was a connection that was actually more reliable than factory couplings and could be disassembled and reused indefinitely. Jake explained that this knowledge came from an era when people fixed things instead of throwing them away. His father had been a plumber during the Depression when wasting materials wasn't an option. Every scrap of metal, every piece of rubber, every fitting had value and was repaired until it absolutely couldn't be used anymore. Quote 4, quote, Jake explained. Quote 5, quote, if these simple fixes are blowing your mind, hit that subscribe button and give this video a thumbs up. We're just getting started with money-saving repairs they don't want you to know about. The economics were staggering when Tom calculated his potential savings. Over the past 5 years, he'd spent over $400 on hoses and fittings. Jake's repairs used materials that cost less than $10 total and would last longer than Tom would probably need them. A bicycle inner tube costs about $3 and provides enough material for 20 or more hose repairs. A box of hose clamps costs $5 and contains enough hardware for dozens of permanent connections. Jake also revealed why hardware stores actively discourage these repair methods. The profit margin on a $2 hose clamp is minimal compared to a $20 quick connect fitting that needs to be replaced every season. Store employees are trained to sell solutions, not to solve problems permanently. They'll gladly sell you a $30 hose repair kit, but they'll never mention that a bicycle patch kit from the sporting goods section could fix the same problem for 50 cents. The planned obsolescence in modern hose design is intentional and systematic. Jake explained how hoses from the 1970s and 1980s were built with thicker walls, better rubber compounds, and metal fittings that lasted decades. Modern hoses use thinner walls and plastic components specifically designed to fail within a few seasons. This forces consumers into a continuous replacement cycle that generates enormous profits for manufacturers and retailers. Tom learned that the rubber compounds used in modern hose construction are formulated to degrade quickly when exposed to UV light and ozone. The same environmental factors that make outdoor watering necessary also destroy the equipment used for watering. Jake's hoses from the 1980s were made with rubber compounds that actually improved with age, becoming more flexible and durable over time. Modern hoses become brittle and crack within 2 or 3 seasons of normal use. The connection hardware tells an even more disturbing story. Original brass fittings from older hoses can be completely rebuilt using replacement threads and gaskets that cost pennies. Modern plastic quick connect systems are designed as sealed units that cannot be serviced or repaired. When they fail, the entire fitting must be discarded and replaced. This design philosophy extends to every component of modern garden irrigation equipment. Jake demonstrated how to identify hoses worth repairing versus those designed to fail. Quality hoses have consistent wall thickness, brass or stainless steel fittings, and rubber that remains flexible even when cold. Cheap hoses have thin spots near the connections, plastic fittings that crack under pressure, and rubber that becomes stiff when temperatures drop. Learning to recognize these differences could save any gardener hundreds of dollars over their lifetime. The bicycle inner tube material that forms the foundation of Jake's repair system has properties that make it superior to manufactured gaskets. Bicycle tubes are designed to hold air pressure under extreme stress while remaining flexible across a wide temperature range. When used as gasket material, they conform perfectly to irregular surfaces and maintain their seal indefinitely. Unlike manufactured rubber gaskets that are molded into specific shapes, inner tube material can be cut to fit any application perfectly. Tom was amazed to learn that Jake's repair techniques worked on more than just garden hoses. The same methods could repair pressure washer hoses, pool cleaning equipment, and even some automotive cooling system hoses. The principles of creating flexible, pressure-resistant seals with bicycle tube material and hose clamps applied to dozens of different applications around the home and workshop. Jake showed Tom how to extend the life of new hoses before they needed repair. Simple maintenance, like storing hoses out of direct sunlight, draining them completely after use, and avoiding kinks that stress the rubber could extend hose life from 2 or 3 seasons to 10 or 15 seasons. Most hose failures were preventable with basic care that took just a few minutes after each use. The water conservation implications were enormous. Jake calculated that the average household loses over 1,000 gallons of water per season through hose leaks and connection failures. In areas facing water restrictions or high utility costs, this waste represents both environmental irresponsibility and significant financial loss. Proper hose maintenance and repair wasn't just about saving money on equipment. It was about responsible resource management. Tom discovered that Jake's techniques could also improve water pressure and flow rate even in undamaged hoses. Many factory connections create turbulence and flow restrictions that reduce water delivery efficiency. Jake's smooth-bore connections actually improved water flow compared to the quick connect fittings they replaced. Tom's sprinklers worked better after Jake's repairs than they had when the equipment was brand new. The temperature resistance of Jake's repairs proved superior to manufactured fittings in unexpected ways. Arizona summers regularly exceeded 110 degrees Fahrenheit, temperatures that made plastic fittings brittle and prone to sudden failure. The bicycle tube gaskets actually performed better in extreme heat, maintaining their flexibility and seal integrity when plastic components would crack or warp. This meant fewer emergency repairs during peak watering season. Jake explained the historical context that led to the current disposable mentality around garden equipment. During the post-World War II economic boom, manufacturers discovered that selling replacement products was more profitable than selling durable goods that lasted decades. Marketing campaigns convinced consumers that newer was always better, even when older products were functionally superior. This mentality spread from automobiles and appliances to garden equipment and tools. The repair techniques Jake taught had been standard practice in commercial agriculture for generations. Farmers couldn't afford to replace irrigation equipment every season, so they developed methods for maintaining and repairing equipment that needed to last for decades. These techniques were gradually abandoned in residential applications, as homeowners were convinced that replacement was easier than repair. Tom learned to recognize the signs of impending hose failure before catastrophic leaks developed. Small bubbles in the hose wall indicated that internal separation was beginning. Stiffness in rubber that was normally flexible suggested that UV degradation was advanced. Discovering these early warning signs allowed preventive repairs that were much easier than emergency fixes during peak gardening season. The sourcing of repair materials became part of Tom's new routine. Bicycle shops often threw away inner tubes with small punctures that were perfect for hose repair applications. Auto parts stores sold hose clamps in bulk quantities that reduced the cost per unit dramatically. Thrift stores and garage sales provided sources of old-style hoses with brass fittings that could be restored to like-new condition with minimal effort. Jake's system included techniques for improving new equipment before it failed. Adding hose clamps over factory connections provided backup security that prevented common failure modes. Wrapping connection points with electrical tape before problems developed could extend the life of plastic fittings significantly. These preventive measures took minutes to implement, but could prevent hours of frustration and water waste later. The environmental impact of Jake's approach extended beyond water conservation. The average American household discards over 50 pounds of garden equipment annually, much of it hoses and fittings that could be easily repaired. This waste stream includes rubber compounds that don't biodegrade and plastic components that persist in landfills for centuries. Repair-based thinking could reduce this waste stream by over 80%. Tom discovered that Jake's knowledge extended to improvising new tools and accessories from materials that would otherwise be discarded. Old garden hoses could be converted into protective sleeves for tree trunks, drainage systems for container gardens, or even heating systems for cold weather growing. Instead of viewing damaged hoses as waste, Jake saw them as raw materials for other applications. The social aspect of Jake's repair philosophy created community connections that the disposable economy had eliminated. Neighbors began sharing tools, materials, and knowledge as word spread about effective repair techniques. Tom found himself teaching Jake's methods to other gardeners, creating a network of people who supported each other's self-sufficiency instead of depending on retail solutions for every problem. Jake revealed that his knowledge came from mentors who had learned these techniques during wartime rationing, when materials were scarce and expensive. These methods were developed under conditions where failure to repair equipment meant crops failed and families went hungry. The stakes were high enough that people developed solutions that worked reliably under extreme conditions. Modern consumers had lost this knowledge because the stakes seemed lower. But the underlying principles were just as valid. The confidence that came from mastering repair techniques transformed Tom's relationship with all his garden equipment. Instead of feeling helpless when something broke, he approached problems with curiosity and creativity. This mindset shift extended beyond garden hoses to other areas where he'd previously felt dependent on retail solutions. Learning to fix things permanently was empowering in ways that went far beyond monetary savings. Tom also learned that the quality of repair materials often exceeded the quality of original components. Stainless steel hose clamps were more corrosion-resistant than the brass fittings they replaced. Bicycle inner tube material was more durable than the molded rubber gaskets in plastic connectors. In many cases, proper repairs created equipment that performed better than factory specifications. The timing of repairs became a strategic consideration. Jake taught Tom to stockpile repair materials during off-season when prices were lower and selection was better. Having the right materials on hand meant that repairs could be completed immediately when problems developed, rather than delaying while shopping for parts. This preparedness prevented small problems from becoming large disasters. By the end of his first season, using Jake's techniques, Tom had repaired over a dozen hose problems that would have previously required equipment replacement. His water bill decreased by 30% due to eliminated leaks. His irrigation system worked more reliably because connections were actually stronger than original specifications. Most importantly, he developed skills and confidence that made him less dependent on retail solutions for routine maintenance problems. Jake's approach represented a different philosophy about the relationship between consumers and their possessions. Instead of viewing garden equipment as disposable commodities, his methods treated them as tools worth maintaining and improving. This shift in perspective led to better equipment performance, lower costs, and greater self-sufficiency. It also created a more sustainable relationship with material possessions that honored the resources and labor that went into their creation. The knowledge that Jake shared wasn't just about fixing hoses. It was about reclaiming the ability to solve problems independently using materials and techniques that worked better than manufactured solutions. In a world designed to keep consumers dependent on retail channels for every need, these skills represented a form of resistance that was both practical and empowering. Today, 3 years after learning Jake's techniques, Tom hasn't purchased a single hose or fitting. His irrigation system works better than ever, and he's become the neighborhood go-to person for equipment repairs that others would throw away. The skills Jake shared have saved Tom over $1,000 and countless hours of frustration dealing with equipment failures during critical watering periods. The story of Tom and Jake illustrates how simple knowledge can transform someone's relationship with everyday technology. The difference between depending on retail solutions and being able to fix things yourself is often just information that's been deliberately kept from consumers. Once you understand how things really work and what repair options exist, the power dynamic shifts dramatically in your favor. Have you tried any of these hose repair techniques? Or do you know other ways to fix garden equipment that hardware stores don't want you to know about? Share your experiences and discoveries in the comments below. And if this video has opened your eyes to the possibilities of permanent repairs instead of constant replacement, make sure to subscribe to our channel for more forgotten techniques that can save you money and frustration while making your equipment work better than ever.